In this video, we're going to talk about greatest common factor and factor by grouping. So some of the things that you need to do to identify the greatest common factor. First of all, a factor is an integer. To write an integer as a product of two or more integers. So factors of 12, that could be 1 times 12, it could be 2 times 6, it could be 3 times 4. Those are all factors of 12. So when you factor an integer, 12 is an integer, you write the integer as a product of two or more integers. Okay? Factoring a polynomial is to express the polynomial as the product of two or more polynomials, which we will get to. And then prime factorization of an integer is to write the integer as a product of prime numbers. Now, we're going to focus on the greatest common factor. We are going to do a separate method, factor by grouping, because it involves the greatest common factor concept. So the greatest common factor, by definition, of two or more expressions is the product of the common factors, where each factor is raised to the lowest power to which it occurs in all the original expressions. So in the first example, we have nothing but numbers. So what we're going to do is we're going to list all the factors of 12. That would be 2 times 2 times 3. Now, if you remember a factor tree, I said 2 times 6, and then I broke 6 down further. 2 and 3, they're all prime numbers. You can't break them up any further like you can 6. So that's where those 3 numbers come from. And then I have factors of 90. I can do that the same exact way. I can break 90 up into 2 and 45. I could have done 3 and 30. It does not matter. Then I can say 5 times 9, and then 9 breaks up into 3 times 3. So I have 2 times 3 times 3 times 5. So those are the prime factors of 90. So once I do that, I need to see what the two numbers 12 and 90 have in common. Well, they both have a 2, and they both have a 3. They have nothing else in common. So the greatest common factor is the product of all the factors that they have in common, which are 2 and 3. So the greatest common factor between 12 and 90 is 6. Now, when you get into number 2 and they start pulling variables in the mix, you have to remember what they said right here. The product of a common factor, where each factor is raised to the lowest power to which it occurs in all the original expressions. So when we get to the variable part, that's going to be the easier part. So I'm going to break down 24 and 36. So using my prime factor tree, 24 has the factors of 2 and 12, 2 and 6, 2 and 3. 36 breaks down into 2 and 18, 2 and 9, and then 3 and 3. So what they have in common, they both have a 2. So as far as 24 and 36, we have a 2, we have another pair of 2s, and then we have a pair of 3s. So our greatest common factor is 12. Now, some of you may have already known that, and you don't have to do the factor tree, but that's a good way to make sure that you get the biggest common factor. Now, as far as the variables are concerned, I have an a to the third, and I have an a to the fourth. Well, based on my rule right here, I take the one with the lowest power. So I'm going to keep my number, and I'm going to include a to the third, because that power is lower than a to the fourth. Well, when I look at my b values, when I look at the b numbers, both of them are b to the first. So I keep ab to the first. That would be the greatest common factor for the number and the variables in each one of these monomials. In the third example, we have three monomials, so we've got to get the greatest common factor here. Now, some of you may already tell that the greatest common factor is 3, but I am going to break down the numbers so you can see where the 3 comes from. 27, that's 3 times 9 and 3 times 3. 6 breaks down into 2 times 3, and 24 we did up here, so I'm going to go back up and grab that. That would be 2 times 12, 2 times 6, and 2 times 3. Well, the only thing these three numbers have in common is a 3. Now, I know that 6 and 24 have a 2 in common, but 27 doesn't have a 2. All of those numbers need to be included for 27, 6, or 24, or you can't keep that answer. So right now, as far as those three numbers, 3 is the largest common factor. Now, when I look across, I see an X here, but I do not see an X here. So since the last term, the 24yz to the fourth, does not have an X, they do not all have an X in common. So I do not put down an X at all. Okay. Now, the next thing I do is I move to the next variable, which is y. The smallest y I have is y to the first power. All three of those have nothing but y to the first power. And then if you notice, all three terms have a z. You take the smallest power, which would be just z to the first power. So therefore, my common factor for number 3 would be 3yz. 4 is a little bit different, and this kind of leads us into our discussion that we'll have in a few minutes about greatest common factoring. Now, this is considered a term, and this is considered a term. If you have groups like that, those groups are considered a term. So you're multiplying 8 times the group, and that's okay. So if you notice the greatest common factor, each group has a 2x minus 3 in it. So that would be your greatest common factor with respect to number 4 and the groups involved. So sometimes you're going to take out just a monomial factor, like the 3yz that we did in number 3, and sometimes you're going to take out a group with a binomial in it, like we did in number 4. Now, factoring out the greatest common factor is a little bit different. So what we're going to do the whole thing this time. So what we're basically doing is we are going to undistribute. We're going to reverse the distributive process. So like if you had 2 times x plus 4 and you distributed it, you would get 2x plus 8. Well, what we're going to do is we're going to start with the 2x plus 8, and we're going to work our way backwards to the 2 times the group x plus 4. So first step is to identify the greatest common factor of all the terms in the polynomial, which means numbers and variables if possible. You're going to write each term as the product of the greatest common factor and another factor, and then you're going to use the distributive property to remove the greatest common factor. So this step 3 is where we're going to actually go backwards like we did or we could do in that example. Okay. Now, just to give you an idea of using the distributive property, here again, 4 times 3x is 12x, and 4 times negative 7 is negative 28. Now, to undo this, notice that this answer is the same as what they're asking you to do. So they're asking you to use the distributive property to factor, which means you've got to break up the factors. So just in case you don't see, now I know both of those numbers are divisible by 4. So I know they have a 4 in common. 3 and 7 are both prime, so I can't use those. So sometimes you don't have to use the smallest prime number. If you know that there is a number that you can divide 12 and 28 by, like 4, you can use that instead because you're showing that they have a 4 in common. So we're going to take out the 4, and your thought process should be 12 divided by 4 is 3, bring along the x, and 28 divided by 4 is going to be negative 7. So you're going to go backwards, and I'll go through those steps every single time I do this. All right. So the next 5 examples, we're going to do nothing but greatest common factor. So when I look at 6 and 14, I know both of those numbers are divisible by 2. So 2 and 3, 2 and 7. Well, I know they have a 2 in common, but 3 and 7 are prime. They'd have nothing in common. So I'm going to factor out a 2. Now, before I say 2 is the only thing I can factor out, I look for variables. Well, the first term has a variable, but the second one doesn't, which means they do not have a variable in common. So I've got my greatest common factor, and I should be reducing the terms that I put back in. So 6 divided by 2, 3, carry along the x. Negative 7 divided by 2, or negative 14 divided by 2 is negative 7. Got ahead of myself with my answer. Okay, now, before you mark this as your answer, always check, does 3x or do 3x and negative 7 have anything in common? They do not, so this would be my final answer. In number 7, if you notice, the first thing I notice about the numbers, 14, 21, and 28, there are 3 separate terms. I know that they are all divisible by 7. So 14 is divisible by 7, 21 is divisible by 7, and 28 is also divisible by 7. Now, 2, 3, and 4 do not have anything in common. I know that these two have a 2 in common, but this one does not. Okay, so I cannot bring along a 2. That 2 has to be involved in all 3 of those bigger numbers, or you can't use it. So 7 is my numerical value for 14, 21, and 28. And if you notice, I have an F in all of those scenarios. So the smallest power is F to the first in the last term, that last term. Sorry, trying to make me some room. Technical difficulties with my pen this morning. Now, what I'm going to do is I'm going to divide the number. 14 divided by 7 is 2, and I subtract the exponent. So 3 minus 1 is f squared. I'm only taking one of those 3 powers away. 21 divided by 7 is 3. Subtract your exponent. And 28 divided by 7 is 4. And when you subtract the exponent, 1 minus 1 is 0. So therefore, you do not have an F in the last problem. So this would be my answer. And if you notice, these 3 terms have nothing in common with respect to each other. All of the terms have to have something in common, or none of them do. Okay. Number 8. The first thing I see is a greatest common factor of 5, because I know 5 goes into 20 and 5 is a factor of itself. The next thing I look at is my variables. Both of these terms have an m, so I'm going to take the smaller exponent. They both have an n, so I take the smaller exponent. What goes back in the parentheses, if you start with 2 terms, you end with 2 terms. So 20 divided by 5 is 4. Subtract the exponent. 3 minus 2 is 1. 4 minus 2 is 2. 5 divided by 5 is 1, not 0. And when you subtract the exponents, 2 minus 2 is 0, and 2 minus 2 is 0 for the m and the n, so they go away. So therefore, let's clean this up just a little bit. your final answer has a greatest common factor of 5m squared n squared, and then the reduced two terms left over. In number 9, when I look at these two terms, I have an a here, but I do not have an a over here. They have absolutely nothing in common. This is considered to be a prime polynomial when all the terms involved have absolutely nothing in common. Technically, officially, the only thing they have in common is a 1, but factoring out a 1 does not do us any good because it's 1. All right. Now, this one has 4 terms this time. I have 1, 2, 3, 4 terms. Now, the 4 numbers involved, there's an 8, a 1, a -6, and a 1. There's an understood 1 in front of the second and the 4th term. Now, since those 1s are there, I do not have a number that I can take out with respect to these 4 terms. So now I'm going to turn my attention to the variables. Now, if you notice, all 4 terms have an a. The smallest exponent, the smallest power on those a's, is an a squared. When I look at all 4 terms, I have a b, and the smallest power is b to the first. So since I do not have to reduce numbers, I do have to subtract my exponents. So my 8 stays, I'm working here. 2 minus 2 is 0, and 1 minus 1 is 0. So I go to the next term. 3 minus 2 is a to the first, b to the fourth minus b. 4 minus 1 is b to the third. Then I carry my -6 along. 3 minus 2 is 1, and 2 minus 1 is also 1. And in the last term, the 4 minus 2 on the a is an a squared, and the b to the third minus b is also a b squared. Now, this would be my final answer. When you look in your parentheses, none of those terms have anything else in common besides a 1. 8 does not have an a or a b, so that knocks out all the terms that have a's and b's. It's all 4 of the terms having something in common or none of them. So what's in the box would be your final answer. A squared b is your greatest common factor, and the rest of it is the reduced polynomial that was left behind. Now, when we get to factoring out a negative, you never want to leave a leading term, your front term, as negative. So in number 11, it talks about factoring out the greatest common factor of a -3g. Now, it tells you up here it's a good idea, basically, to take out the opposite of the greatest common factor when the leading number is negative. When you do that, this part right here is extremely important. This changes all the signs of the remaining terms that you put back inside your parentheses. So if I factor out in number 11 a -3g, that's what they're telling me to do. When I divide a negative by a negative, it becomes a positive. Subtract that exponent and I get 3. When I take out -6 divided by -2 or -3, I get +2. Subtract my exponent. A +9 divided by that -3 out in front gives me -3. And when I subtract my exponents, my g's go away because 1 minus 1 is 0. So I have a negative common factor, and I only do that if my leading term is negative. And then everything that goes back in the parentheses has the opposite sign of what it originally was. Now, over here, this simply says factor out a +3g. So when I do that, if I factor out a positive, all the signs remain the same. So a -3 divided by a +3 is a negative. Subtract those exponents. A negative 6 divided by a positive 3 stays negative 2, subtract your exponent. And positive 3 divided by, or positive 9 divided by positive 3 stays positive 3. So notice that my signs did not change when I factored out a positive. So it is extremely important that you pay attention. If that leading number is negative, pull the negative out with it when you factor. So the next couple of examples are going to be doing just that. So in number 12, the greatest common factor, I have a -1, a -2, and a 5. The greatest common factor between those two numbers is a 1. Now, since my first term is negative, I am going to take out -1. The next thing I look for is the fact that all of my terms have a b. All three terms have b, so I take the smallest exponent. So now it's a matter of changing my signs and subtracting my exponents. A negative divided by a negative is a positive. Subtract your exponents. A negative divided by a negative is a positive. Subtract your exponent. And a positive divided by a negative becomes a negative, and subtract your exponents. Now, the one thing that you do not have to write down is you do not physically have to put a -1. You do not have to put the number 1. When you see negative b, it is understood that there is a 1 there. You don't have to type it. Now, if you type that in, the program may tell you, although your answer is correct, it's not necessary to put the 1, but it shouldn't mark it wrong. And if it does, just contact me and let me know. So in the next example, the only thing you can take out is a -1, because your numbers, -2, 5, and -1, the only thing they have in common is 1. And since the leading term is negative, we're going to take out the negative. So basically, we put everything back in, but we change the signs. A negative divided by a negative becomes a positive. Positive divided by negative becomes a negative. And negative divided by positive becomes a positive. They have no variables in common or anything like that, so that is all that we can do with that. Now, we are going to get into the second part of this lesson, and I know this lesson is a little bit longer than I would like it to be, but there's a lot of material in here. So factoring out the greatest common factor as a group, factoring out what they call a binomial factor, and that's what that group is. So if you notice here, what's in the boxes, both of those groups of items have a parentheses that's exactly the same. So what we're going to do is we're going to factor out the x squared plus 1. When we do that, we write down what we see left behind. So 7 minus 6y goes in a totally separate group. Now, that is what you get when you take out that common group. In number 13, the common group is w squared minus 5. So when I remove those, I'm not canceling them, I'm removing them. I get 3c with a plus 1. Now, you do not physically see the 1, but it is understood to be there. If you have two groups, you have to put two terms back, even if one of those terms just so happens to be a 1. And that's one of the harder parts for students to kind of grasp when they're doing the factor by grouping. All right, so now we're going to do a couple of examples with straight up nothing but factor by grouping. So you identify and factor out the common factor from all the terms. Then you will factor out, in step 2, you'll factor out the greatest common factor from the first pair of terms, then the second pair of terms. And sometimes it is okay to factor out a negative if your leading number is negative, and I'll show you one of those. And then step 3, if the two terms share a common binomial factor, or if their parentheses group is exactly the same, you can factor that out and do what we did up here in these two problems, 14 and 15. All right, so the first thing you want to look at is all the way across. I have 3, -6, 2, and -4. With respect to all four numbers, they do not have a greatest common factor. 3 and 6 have a 3 in common. 2 and 4 have a 2 in common, and even 2 and 6 have a 2 in common. But since 3 does not have that 2 in common, you do not have a common factor. If you look all the way across, all the terms do not have A and B. Some of them have A's, some of them have B's, but not all four of them have A and B. So we have no greatest common factor. So now what we're going to do is we're going to split this down the middle. So I'm going to look at 3A minus 6B, and I'm going to look at positive 2A squared minus 4AB. And I'm going to take out the greatest common factor for each set of numbers. So in the first group, greatest common factor is a 3. They have no variables in common, so I'm going to put a reduced binomial back. 3 divided by 3 is 1, so that's 1A. -6 divided by 3 would become -2 and bring along the B. Now, when I move into the second group of terms, I'm going to take out the greatest common factor of 2. Also, if you notice, both of the terms in this box have an A, so I'm going to take out an A. So now I need to put 2 reduced terms back. 2 divided by 2 is 1. Subtract your exponents. -2 divided by 2 is -2. Subtract the exponents, so the A's cancel and leaves me with B. Now, when I get to this point, if you notice, both groups in each scenario are exactly the same. Both groups have a parentheses with an A minus 2B in them. So I'm going to pull out that A minus 2B. And then I'm going to write down exactly what I see, a 3A and a positive, or a 3 and a positive 2A. And that would be my final factor by grouping groups. In number 17, I'm going to do the same thing. As I look across 6, -4, -15, and 10, they do not all have something in common. 6, 4, and 10 have something in common, but 15 doesn't. 6, 4, and 10 have a 2 as a factor, but 15 does not. So if you can find a scenario where just one of the numbers does not work, like the 15 in this case, then you don't have a greatest common factor as far as numbers. As I look across the problem, some of the terms have x's, but not all of them have the variable x. So I don't even have an x in common. So I am going to split this problem in the middle. So I'm going to look at the first two terms, and I'm going to look at the last two terms. Notice that I kept the sign with that third term. That was a -15, so I kept the negative with that term. So in the first two, I'm focused right here on the 6x squared minus 4x. I do have a 2 in common, and since both of them have an x, I take the smaller exponent. Now I'm going to put the reduced terms back in. 6 divided by 2 is 3. Subtract that exponent. -4 divided by 2 is -2. When I subtract the exponent, I get 0 because 1 minus 1 is 0. So all I get is the -2 when I did -4 divided by 2. Now in the second group, I can clearly see that 15 and 10 have a 5 in common, but since this is leading term is negative, I'm going to take out the -5, which means when I put terms back in, the signs are going to change. So -15 divided by -5 is +3, bring along the x. +10 divided by -5 would be a -2. Now in doing that, if you notice, my groups end up being the same. Now, hypothetically, if you get here and your groups are not the same, the first thing I want you to do is go back and check your factoring. And then the second thing I want you to do is just state that it's prime. It cannot be factored. So my common group is the 3x minus 2. Now, remember, I'm not canceling them. I scribble them out so that I can see clearly that I have a 2x and a negative 5 left over that has to be grouped together. So this would be my final answer. Now, you don't have to scribble out those common groups. I'm just a visual person, and that's what I need to do to see what's left over. So the last two examples, we're not going to do the bottom one. The last two examples, I have the number 18, -9, -2, and 1. So none of these numbers have anything in common. As I go across the problem, I have some terms that have A's, but not all of them do. I have some terms that have a B, but not all 4 terms have a B, so I can't take out a greatest common factor. So with this one, I'm going to group the first two together. I'm going to split it right down the middle. Notice that I'm keeping the signs with all the terms. So in the first group, the common factor I have is 9. Both of them have an A, so I'm going to take the smaller power. They both have a B, so I'm going to take that smaller power. So I'm going to put the reduced terms back. So 18 divided by 9 is 2. Subtract the exponent on A, and when I subtract the exponents on B, they cancel. -9 divided by 9 is -1. Subtract the exponent on A, subtract, and it goes away, subtract the exponent on B, so I'm left with 1B. Now, the next group is very unique because the only thing they have in common is a -1. They really have nothing in common. Everything has a 1 in common. So sometimes all you can do is factor out either a +1 or a -1. Now, the reason I took out a -1 is because that leading term is negative. So I'm going to pull that out. So -2 divided by -1 is 2a. B divided by -1 turns into -b. Notice when I do that I have a common parentheses, 2a minus b. When I scribble that out, I get the 9a squared b minus 1 as my remaining factor. So the last example that we're going to do actually does have a greatest common factor in it. When I look at the numbers 6, 6, 9, and 9, the greatest common factor, I can divide all of those numbers by 3. So I'm going to take out my 3, and that's going to leave me with 6 divided by 3, which is 2x squared y. 6 divided by 3, which is positive 2x squared. 9 divided by 3, which is 3y to the third. And 9 divided by 3, which would give me 3y squared. Now, my final answer is going to look like this. So let's get to the two groups. So that 3 is already down there. If you take that 3 out, it doesn't go away. It just kind of hangs out in front. So now what I'm going to do is I'm going to focus on the grouping part. I'm going to look at these two terms, then I'm going to look at these two terms and decide what they have in common. So when I look at these two terms, I notice that they both have a 2. They both have an x squared. One of them has a y, the other one doesn't, so I cannot take out that. So the reduced terms, 2 goes into 2 one time. Subtract the exponents on x, you get 0. So the only thing that is left behind is the y. 2 divided by 2 is a 1. Subtract the exponents on x, and you get 0, so the x cancels out. When I go to the second group, not only can I take out the 3 that they have in common, they both have a y, so I'm going to take out the y squared. When I put the reduced terms back, 3 divided by 3 is 1. Subtract the exponent, I get y. 3 divided by 3 is 1. Subtract the exponent, and I just get 1. Now notice my groups are the same. So I'm going to put y plus 1 as the common group. And then the second parentheses gets the 2x squared plus 3y squared. Now, that's a lot of factoring, I know. factor by grouping and greatest common factor, but factor by grouping utilizes greatest common factor. So that's why those two things are set together. So if you have any questions or any concerns about factoring greatest common factors or factor by grouping, please make sure that you let me know.